chart and how it works then before we move on, even though we have covered it before. So let me share my screen. And secondary, like I always say, this is a boot camp. In most of the functions, libraries we do cover, those functions and methods there, we don't cover all of them because most of them have so many of them. So we just pick the ones we think that is necessary. And we do give you guys the syntax. Why we do provide syntax is for you to be able to decode other syntax you will see when you learn on your own. And though some of the syntax will not be explicit like the way I do explain it in full, but at least anytime you see a syntax, with the knowledge you guys have gotten so far, I believe you can be able to grab what the syntax is saying, and you can apply it to your own code. So today, let's kick off with Can you guys see my screen? Can you see my screen? Understand? Oh.
Yes, yes. Yes, I can see your screen.
Okay.
I can see your screen.
So, yeah. So, like I said, the basic things we use NumPy library to do is to perform numerical operations and then basic statistics. When we talk about statistics in our secondary school, university days, and anytime we talk about statistics with respect to number, what always comes to our mind is talking about the mean, median, standard deviations, and so on and so forth. So for you to perform all these statistics on your data, NumPy has those functions that will help you to carry out those activities on your data. Now, why this thing is important is sometimes you might decide to know the maximum age in your data. Maybe if you have an age column, I decide to know, like in our data we are working with, where we have age, fair, and all those things. You can decide to know the maximum, the minimum, the number of so people, and so on and so forth. This is part of having insight of what is in your data. And we use mostly this NumPy on numeric data. Even though when we go into machine learning, because the only thing computer understands is numbers. So even if we have those ones that are strange, we still have to look for a way to convert them to numbers before we push it for computer to learn the patterns. But when we get there, we'll try as much as possible to explain it the way we understand, so it will not be too complicated to us. So most of the built-in functions of the NumPy we'll look at today is talk about the mean, median, standard deviation, variance, sum, and so on. And there are other things where we can use this, which we explain further in this class. I believe this class don't want it to pass more than 1 hour so that we'll be able to assimilate anything we're able to cover. And we'll move on. So first of all, this syntax is for us to import our data. We are still working with our Titanic data set, which this is not new to us. We have talked about pandas library. So we use import pandas to bring the library to our environment. And we are giving it an initial, which is PD, sort of, do call, if it is in our street or these things, we say guy name or something. But this one is just like an initial to the pandas, so that anywhere we are meant to use pandas, we can easily write PD, and the environment will understand what we are saying. So this PD is what is being used in most cases, but that does not mean that it must be PD. This thing is just any variable form you put to assign, even if you put OO, anytime you talk OO in your code, the computer will know that you are talking about pandas. So any initial you put here, you can use it over here in your code. But in data analysis world, we use PD in most cases, even in textbooks, they make use of PD. So this line is for us to import our data, which the file name is Titanic dataset.csv. And this one is for us to view the first 10 rows in our data set. So when we execute this, I've already uploaded the data set here. So when we execute this, we have this. This is, I believe we have been seeing this. So now, when you look at this, you find out that our passenger ID is numeric form, survived is numeric form, P class, age, SIP, SP, patch, and fare. All these ones are in numeric form, which implies that most of the activities we perform with regards to NumPy will be on this. But that does not mean we cannot use, there are some we'll do with sex and embark, where we'll do a sort of to count how many females we have, how many males we have, and so on. It's still part of the mathematical operations. NumPy helps you to perform such. So we'll see more of those things over here. But when it comes to perform something like a mean, median, standard deviation, all those ones that is not just counting, we have to focus more on the numeric data. That is those ones that are numbers. This one is alphanumeric because it has both number and alphabet. So this thing is a string. And like I told you guys before, in this data frame in pandas, pandas see all these strange variable as an object based on what we discussed before. So you see all these ones that the data type is object. So the first built-in function of the NumPy is the mean. Like we all know, when you talk about mean, what the mean is all about is for you to get the average value of a set of numbers. Let's say, for example, here, we have age. This age, like we know, this thing is how many data set do we have here? df.shape. I think this syntax is for you to know the shape of your data. So we're having 891,12, which is we are having 891 rows and 12 columns. So that means the number of age we have here, we have from 0 to 899, that is 800 and from 0 to 890, because it's counting the index from 0, which is total number of age we have is 891. And now we want to find the average age that we have here. The average age is to sum up all the age and divide it by 891. That is what will give us the mean age. Now, we don't need to be summing 111 before we now count to 891. We can just use a single line of code with the help of the NumPy library built-in function to perform that. And before we move ahead, this is the syntax for the mean. It's not a must you have this, but I always like to create a variable where we assign anything we perform here. Anything we perform here, we assign it to any variable we put in the left-hand side. But in most cases, it's not a must. You might not really put this. When you perform something like this, it will still work. When you perform only this particular syntax. But I always want to assign it to a particular variable so that when we need that information, we can call on that variable to provide it for us. And since we are working with a new library, in Python, any library you want to work with those built-in function meant for that particular library, you have to first of all import that library to the environment. And our NumPy, this is the way we import NumPy. When you look at this, we have import NumPy as NP. This is also like the same way we did pandas. You know, in pandas, we give pandas an initial, which is PD. But this is our NumPy, we are giving it NP, so that in any of those built-in function, anytime we want to mention NumPy, we can easily type NP, and the computer will understand what we are referring to. So when you look at this syntax for the mean, which started from here, because this one is just, we are creating this variable to assign anything we perform in the right-hand side inside the variable. This is the syntax. The syntax is np.mean. That is numpy.mean. Then you have your parentheses. You now provide any of the desired column here that you want to perform the mean on. So from here, in our second line of code here, this mean age is just a variable name that we just created. You can put anything you like over there. In order, so this mean age will hold any action we perform in the right-hand side will be assigned inside the mean age. So that anytime we want to view the result, we'll just call the mean age and our result will display. So when you look at this particular syntax, we have our np.mean. So we have to pick the particular column we want. Like I told you, this is the syntax we normally use when you want to pick a particular column. This df is the name of the variable that is holding the whole data we imported. And we just inform it to pick out the column for age. So we have age as part of the column here. This is the age. And the variable holding it is df. So when we call this df, pick age. So what it will find, since we are using the mean function, it will sum up everything under age and give us the mean value. So this one is just our normal print function. This one is our normal print function, which I told you that anything inside the print function, this parenthesis that is enclosed in double quotation mark, the computer will print it that same way. I think we did it in one of our classes. And then this one is the variable name. So what it implies is that the computer will print this the way it is, and then pick the value inside here and display. So that will be saying our mean age is, it will go and check the output of what we have here, which is being assigned inside the mean age. It will display it for us over here. So when we execute the code, now have that our mean age is 29.69, blah, 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 blah. So this is the mean age. That is summing the whole age we have in that column for age and dividing it by the number of counts. That is how we got this mean age. Any question? Is that understood? Oh, okay. Okay. So the next one we have is the sum. What the sum does is to add all the elements together. Maybe in a particular column, you want to have the summation of all the elements in that particular column. We use the sum function in our NumPy. So the syntax to do this, like I told you guys, I always like to create a variable that will be holding any action we perform here for us. So the syntax we use is np.sum, pick out the particular column we want to sum everything inside. It will give us, and it will assign it inside here. And also, where we use this sum also in data analysis is you can create a condition of what you want a computer to sum. Let's say, for example, if we come to this our data set, here that we have survived, if we can instruct the computer to sum everything in survive, what the computer will be summing is 0 plus 1 plus 1 plus 1 plus 0 till the end. But since from our data set initially, when they were giving us information about our data set, they were telling us that 1 is for those people that survive and 0 is for people that did not survive. We might decide to tell the computer and give it a condition that the people we want to sum are those zeros, those people that did not survive. So what the computer will do is that it will count the number of zeros and sum them together. So that maybe if it is this data set we have now, all these ones we are seeing, if you give it a condition that what we want it to sum is anywhere the survive is 0. So now what it will do is that it will count 1, 2, 3, 4, 5, and give us that our answer is 5. Because we are using the sum with a condition. But as mean that we just say sum this survive, it's not seeing this 0 as anything. What it will be doing is 0 plus 1 plus 2 plus 3. So that's why in this syntax, where we say that we can also state a condition when we are using the sum. Here, we can also perform sum based on a condition. So you can say, okay, the sum I want to do is where we have zeros. We want to know people that did not survive. Count them for me, instead of doing the sum of the whole column. Is that understood? Before we go to the code. Okay, thank you. Okay, so another point to note here, if you use this particular sum in a strange column or variable, what we mean by a strange column is where you have here that we have alphabets sets. So what it will do is that it will concatenate. What do we mean by concatenating? It will not sum because it cannot sum alphabets, but what it will do is that it will concatenate the two values together. Let's say, for example, something like here, you are telling it to sum because it's addition that is doing in the sum, A plus B. What it will give you as the output is AB. That is what it will give you as the output. When you perform this summation on a column that is made up of strange variable. So now, from this example here, okay, want to perform a sum. This one is just a variable name that we want it to hold our summations. And we say np.sum. The column we are picking is sex. And you know that our sex column is made up of strange, which is female, male, female, male, that we have under our sex. I will now say, okay, print the summation of this thing for us. So when we run this code, we find out the output that is giving us. It's giving us male, female, 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 female. What it's doing here now is that it has gone to this column. We have male, female, 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 male. It's just merging all of them together. Because on a real sense, we don't necessarily need to perform a summation on a strange variable. Where you can have a meaning when you perform a summation is when you are doing it on a numeric data types. So that's why when we perform the sum here, It's giving us an output that doesn't make sense, which is mel. It's just concatenating everything together. This one is from our string, what we put inside the string. And this one now is the value that is inside here, which is male, female, female, and so on. So now we move on to perform this same sum in survive. In our survive column, we have numbers, which is 0, 1, 0, 1. And we ask this syntax now, which is np.sum. This one is for us to pick the particular column that we want. df is the variable that is holding our data, and this survive is a particular column name in our data set. So when we perform this summation, what it will do is that it will sum the whole numbers existing inside that our column called survive. So when we perform when we run the code, it's giving us that our survive count is equal to 342. So what it does here is, from this survive, is doing 0 plus 1 plus 1 plus 1 plus 0 plus 0 plus 0 plus 1 till the end. That is the summation that it performs over here. So that's why we have 342. Is that understood? Okay. Any questions so far? Okay, thank you. Now, we want to perform something in a column with a condition when using the sum. So over here, from this line of code, we created a variable called survive, and we are telling the numpy function that we want to sum up where our survive is equal to 1. This one, which is people that did not survive, this thing is just a variable name. Anything you put here, it will accept it, as long as it obeys the rules of naming your variable. And this one is, we also want to sum up where our survive is equal to 0. So it will perform these two actions for us. Now, this is just for us to see, to print out the values. This one will print out the not survive count. This one is the variable name here. So it will print out the content. That is the same thing that will happen here. It will print out the content of survive. So when you execute this, it's now telling us that not survive count is 549, and our survive count is 342. When you check, our survive count is denoted with 1. This our survive count, which is 0342, is the same thing with this first survive count we have here, because here the computer was just adding 0101. So the only meaningful number it will be adding is at the point where it is 1. And that point where it is 1 is where we have survived. That's why these same values are the same. But the counting that is being done here is at the point where it is 0. So it will still count, do the counting, and sum the counting that it did. And we have 549. That means this 0 appeared from this our column here that we have. That means this 0 is 549. 0, 0. You have to count it up to 549 till the end. And this 1, 1, 1 exists 342 times. So that's what this summation with condition performs here. We can still do such in some of our strange variable. Since it is counting that is doing here, because when you put with a condition, it's more of this type of condition we are putting it now is more of go and count. and sum it up. It's different from summing the individual numbers. So we can still perform the summation in this sex, whereby we say, okay, we want to know the sex when it is male. Give us the summation. So what it will do is that it will go and count anywhere we have male and tell you how many they are. So this will help us like to explore our data to know, okay, in this data set, how many males do we have? How many females do we have? So from here, so for the survive we have here. So also we perform the same thing here for the male, for the sex. So for the sex, we say sum up where the sex is male and sum up where the sex is female. If you notice, anytime we want to deal with strange variable, we always enclose it in quotation mark because it's a strange. Numeric values don't need any quotation. Any strange, you have to quote it for the computer to understand what you are saying. So when you execute this, it's telling us that the number of our males is 577 and number of females is 314. Is that understood or any question? Oh, okay. Thank you. So now, since we have gotten this, assuming that you want to present this data, you are not meant to be putting male, female. Not that you cannot just provide it in a written form, but in most cases, it's always advisable to use a sort of visualization to perform such. So, like I said earlier, we are going to use a pie chart to perform our visualization. So I'll just recap to refresh our memory on pie chart, which I know you guys have done bar chart, pie charts under matplotlib. So, like you all know, this is the syntax for pie charts. I will explain all those individual stuff just to refresh your memory. We use the pie chart for the matplotlib.pyplot. This library, we use it for visualization in our Python. And first of all, any library you are using in Python, you must first of all import it to the environment. So we use this particular syntax to import it. And we have as, this one is just to give it a guy name so that anytime we want to type this, instead of typing this long sentence or alphabet, this long word, we just use PLT. So anytime we put PLT, automatically it knows that we are referring to this particular library. And when you want to do a pie chart, we use plt.py. This is the syntax we use. Inside the plt.py, we have these arguments inside. There are more to this, but I think these are the basic ones you are meant to know. The first one is the values. Must be inside this argument. What do we mean by the values? This is what is being expected when they are talking about the values. These are list of values or variables holding your values separated with comma. What do we mean by this? Let's say, for example, we want to put this, our sex, in a pie chart. This is a variable holding the number of male. This one is the one holding the number of female. When you come here, for the survived, as when you want to plot something about the survived, this one is the variable holding your survive, people that survived, and this one is the variable holding people that did not survive. So these are the two things we have been expected inside your value. Now the next one is your labels equals to label list. So you are meant to provide this label list. When we are talking about this label list, any desired label, anything you put as the label, that you want it to appear in your pie chart that will represent those values here, the computer will accept it that way and display it for you in your pie chart. Now we have the color. This one is for you to give the color you want each of your pie charts, because pie chart will divide and say, okay, this one is for male, this one is for female. You choose the color you want the female part to be. You choose the color you want the male part to do. So this color list is where you have to list out those colors that you want. Now, this auto PCT means automatic percentage is represented with auto PCT. So now, this value, you can change this value to the one you want. But what this particular value you are seeing here means is that the first percentage you have here is for you to start. This thing is just for this particular argument here to know that, okay, you want to type in a value. This one, you must start it with this and end it with percentage. Now, the first one you are having here is telling that the minimum number of characters before the decimal point, assuming that we have 50%, 50%, because in pie chart, we'll always show it in percentage. The character that will appear before, because 50% will be like a sort of 50 points, something, that the minimum number that will appear must be 1. So what you are setting here is that you cannot have an empty number. So if the minimum number is 1 character, because 50 is 2 characters, if minimum number is 1 character, means you can have more than 1. When you set it to be 1, means it can be 2, it can be 3, but the minimum that can appear there is 1. And the next one, which is 0.1F, is showing that it is 1 decimal places. What 1 decimal places means that if it is 50% now, it can be 50.0, 50.1, 50.2. It cannot be more than, it cannot be having 50.20. That one would be 2 decimal places. So what you are using this thing is to set that any value is put in your pie chart should have 1 decimal places. And this one is that it must come with a percentage sign. That's what this percentage after the F is denoting. So, but this first percentage and this last percentage is just showing the beginning and the end. The next thing we have here is text props. What these text props do is that the text that will be displayed on your pie chart, you have the control to put any color that you want. Any color that you desire, you can put it. Are you guys with me? Is that understood? Before we now show it. Oh, okay, thank you. So, so now, still on this thing, we have this plt.title. You have control of inside here. Anything you want to, the title you want to give to your pie chart, you have to type it under the plt, inside this plt.title. Inside here, you type any title that you want. And this one will help you to show it. Even though in most cases, even if you did not put this one, your pie chart will still show. But it's always advisable that you put this particular function too, plt.show, to display your pie chart. So now, first of all, we have imported our matplotlib, which is as plt. Now, for our values, since what we are trying to plot is number of male and number of female, remember that this number of male and non-male and non-female are those variables we use to code the number of our male and the number of our female. So that is what we have to impute as our values. Remember, these values, we explained all those things here. I say you have to separate it with comma. So here, non-male, non-female. Now for the label list, we are just typing this because we know that number of male is representing male, number of female is representing female. Since we put the number of male first, we have to, in the label list, you have to give the label first to the first number you input here. Because computer here is garbage in, garbage out. If you put female here, it will accept it, assuming that we put female, it will accept this. Because it's this, you are in control of this list, what you want to label those values. But since we know that what we have here is male, we have to label it properly because the first value here is male, is for male. We have to represent the first value here as male in our label. The second value here is for female. We represent the second one as female. So that's what we have under the label list, where I say that you use a desired label with respect to your values, separated with comma. So we separated it with comma. The next one now is the color you wish to apply on each of those labels. For our male, we want it to come with a black color, and for our female, we want it to come with a gray color. So that is what we did here. So now inside this, our values is inside here. So automatically this will be what the computer will be seeing inside here, since that is the variable holding our non-male and non-female. For our label list, this is what the computer will be seeing, male and female will be inside here. Then for the color list, this thing will be the one inside here. And now for our automatic percentage, we say that we have a minimum of one. There is minimum number of characters should be 1. That's why we have this one. But now we are using 0.3f here, means it must be in 3 decimal places. You know, when we have 0.1 is 1 decimal places. When you have 0.3 means you want 3 decimal places. And then this one is for you to have a percentage sign and it will end. Now this one is for the text that will be written. Which color do we want? So we choose red. You can change all these things to anything that you want. And the title of our chart, we want it to be sex distribution. Maybe it says distribution. I say sex distribution. And make data set. So we can say, okay, this is the title we want our chart to have. And we execute this. So when we execute this, this is what it will show. We find out that the male, we set our male to be black. That's why we're having this black here. We set our female to be gray. That's why we're having this color here. And our text on this, we set it to be red. That's why we have this. And then we set 3 decimal places. That's why you're having 64.75, because we set this to 3 decimal places. We can decide to change, maybe we can change this to blue. And maybe I think we have green. We can change this to green. And execute. So it has changed. So you have power on the color that you want, on how you want to design your pie chart. So now what this thing now is that it's better for us, assuming that you are doing a presentation based on your data, you can easily show them that the percentage of people that are male is this, percentage of people that are female is this, and so on and so forth. Any question? Is that understood? Okay. Okay. This is just like a revision of what you have done before. So we can also do a plot for the survived and not survived. Still the same thing we did here to do the pie chart. These are the values. This one is the one holding the count of people that are survived, people that did not survive. The list, we want to give a label to this as survive, this not survive, color blue, silver, and then so on and so forth. So this one can extend this to maybe 5 decimal places. And we say maybe survived, survive distribution, and execute. Once you execute, because we put it in 5 decimal places, that's why you'll be seeing all this 1, 2, 3, 4, 5. That's why you're having up to 5 decimal places over here, and so on and so forth. So you can alter anything depending on the color and how you want your pie chart to look. So the next function in NumPy we have is what we call standard deviation. Like we all know, what standard deviation in statistics does is for you to know how spread out your numbers are. This one is statistics, so the syntax we use is still the same thing, just that the function for standard deviation is np.std. That is standard deviation. And then you pick the particular column where you want to check the standard deviation of the values inside there. So for here, we decide to choose the one for fair, because our fair here where is our table? So our fair here is in numeric form. This is our fair. So we have 7.2, 71, and so on and so forth. So you can pick to know how to find the standard deviation of the fair. That is knowing how spread out those values are. So, so that's what we did here. And when you execute this, the standard deviation is telling us that our standard deviation is 49 points, blah, 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 blah. So that's our standard deviation. Any question? Is that understood? Okay, thank you. So the next one, the function is to find index location. What do we mean by index location? If you come to this our data set, there is already an index assigned over here my cursor is. All these things are the index numbers, which is from 0 to 890 because of the number of rows that we have. Assuming that we want to know which of the index numbers do we have female, can execute it so that the computer will pick out all those index numbers where we have only female for us. You can also decide to pick out index number where we have people that survived. That is where we have 1, 1, 1 in each of the row. You can use that particular NumPy inbuilt function to pick out, like here we have 1, 2, 3. The next one is 8, assuming that we want to pick out the index numbers where people survived. So here we use the syntax called where. There is. So we use the syntax. This is the syntax we use. mp.where with the condition. So now, assuming we want to find the index numbers where people survived, that is where our survive is equals to 1, that the computer to pick out all the index number where all those things are. So when we execute, it has listed all the index number where we have people that survived. So if you notice, it jumped because the index starts from 0. It jumped the one of 0. It picked 1, 2, 3, 8, 9, 10, and so on. So if we go back to our table, if you go back to our table for people that survived, we have 1, 2, 3, 8, and so on. We have 9, and so on and so forth. So that's what this mp.where helps us to do. You can also pick out where females exist. And also, if you have an exact value that you are looking for, you can also perform it over here with where. So that's all we have for index. Is that understood? Okay, thank you. So it picks out all the index. Now the next one is maximum. Maximum is when you want to find the highest, in a particular list, you want to know the number, the highest number that is existing there. So we can decide to know what is the maximum age that we have in the age column. The syntax we use, variable name mp.max, the desired column, you pick out the column you want and apply the mp.max. This one is the function, numpy built-in function for you to get your maximum mp.max. Then you input your desired column you want it to access. So when we do the one for age, so when we execute, we get 80, which means in that our list, the highest number we have there is 80. Also, you can perform minimum, and for minimum is to know the least number that we have. The function we use to perform that is mp.min. This is the desired column. Maybe you still want to check the minimum age that we have here. And when you execute it with this, when you execute this, it's telling us that the age we have is 0.4. 0.4 age, 0.4 years. Now, we can decide to track which index do we have this particular age. You can use this where to track it, this particular function. You can decide, let's just copy and paste to be fast. So if we should copy and paste, then the computer will want to know, want to pick where age. What is the index where age is 0.42? So it's telling us that it is index 803. So 803 should be towards the down part of our code. So let's check the last rows of our data. We can say df.tail. Let me pick the last 90. So they say that it is in index 803. So this is index 803. I found out that the age there is 0.42. That is the age, which means it's correct with our minimum age is 0.42. It's 10 o'clock. So I think, like I said, I want this class to be 1 hour. I will be stopping here. Any question? Do you guys have any question?
No.
Oh,
on my
thank you.
side.
Okay. I think from Samuel's side, no question. Eukarya, Nero, Chukwuemeka, Ruth. Is that clear? Okay. Oh, thank you. Seems that you guys are getting used to the code, so it's not confusing any longer. Do you have a question, Chukwuemeka? If you have a question, you can unmute and ask. Check your mic. No.
Yes, sir.
Okay, I have question.
Can you check the site? The chat? Can you check the chat? Hello?
Okay.
Can you hear me?
Yeah, I'm with you.
I said, can you check the chat? Because I
Yeah,
dropped
yeah. So,
something
Mr. Chinedu, I
about
think Chukwuemeka was asking, is it possible to control the standard deviation to 3 decimal places?
If we can control the standard deviation, where is our standard deviation?
To 3 decimal places.
Yeah, you can control anything you want in the. Let me go there. Where is our standard deviation? Because most of these things has other arguments you can put inside. For the standard deviation, let me put out the full, some of the arguments you can still have over there. So, assuming that when we wanted to print our variable out, we can decide to control here. Maybe assuming that you want it to appear in maybe 2 decimal places, you can say 2f. So that will not have an error. Yes. So now when you look at this, because the thing is altering our, bringing in more, is bringing in more arguments inside, which I don't want to confuse you guys as someone that is learning the first time. So this argument we have here will help you to control to any number of decimal places that you want. So when you execute this, so we need to remove, I think we don't need this to avoid STTF. But some of these things are always confusing. Okay. So when you execute this, yes, So, but you find out that we are bringing in more informations. What you will be doing, what I always tell my students is, like, you can just go to Google and search, how can I control this to so decimal places? You find out that it will be giving you ideas on what to do. But all these things, when it comes to numbers, you have the power to control anything you want to control. Anything you want to control, you have the power over it. So assuming you want to move it to maybe, let's say we want to 4. You can control it to any number of decimal places that you want. Is that clear?
Yes, it's clear.
Okay, then Eukarya wanted to say something before. Do you have question, Eukarya?
Yeah, I think Igor mentioned that she's fine. She doesn't have any question.
Oh, okay. Thank you. I think we have
Okay.
to stop here.
At this
Then
point, okay, cool.
our next, let me check.